Welcome to Microsoft's online training video series for font developers. This video presents information on creating OpenType tables using Microsoft's Visual OpenType Layout tool, or Volt. This step-by-step guide will show you how Volt is used for creating and adding OpenType tables to a font. This advanced training series is geared for individuals with experience in TrueType font development. OpenType layout tables contain data for glyph definition, glyph substitution, and glyph positioning. OpenType features are organized by script and language, allowing a single font to support multiple writing systems. OpenType provides broader linguistic support and more typographic control. Let's look at some gsub and gpos tables in Volt. Substitution tables provide a way for supporting ligatures, alternate forms, positional forms, and other glyph substitutions. For example, here it is used to substitute the dotless I. Another lookup could be used to substitute positional forms like the medial forms in Arabic. Positioning tables provide a way of aligning glyphs, including accents over base glyphs. In Volt, you can create anchors and simply drag to the desired location. In the same way, you can align below forms and below marks. These substitutions or placements can be constant or contextual, meaning the substitution of position can only happen within a preset context. In this example, the dotless I would only be substituted if followed by an above mark. For more information on OpenType, please visit the Microsoft Typography website. It is critical for the font developer to understand the use of OpenType for the different scripts and language systems. Script-specific OpenType specs are also posted. It is important, too, to understand how the features and lookups interact, and a complete set of the OpenType feature tags are listed and described. Microsoft's Volt provides an easy-to-use graphical interface for adding OpenType layout tables for gsub, gpos, and gdef. Volt enables a type developer to visualize the substitutions and positioning lookups as they are created. Volt also includes a proofing tool that permits the functionality of the font to be tested without having to install the font on the system. Let's look at the menus and windows in Volt. Starting on the left, we have the File menu. Open Font will open one font file at a time. Save Font to write changes to the current file. Save Font As to be saved under a different name. Ship Font will compile the OpenType tables and remove the Volt working tables from the font. This will reduce the file size, the most recently used file list, and the exit to close Volt. Next, we have the Project menu. We have Add Script will add a script to the currently selected writing system. Remove Script will remove the selected script. Add and remove language. Add a feature to the currently selected language, or remove a feature. Note the lookups assigned to the feature that's being deleted are not deleted from the lookup list. You would use the Remove Lookup tool to do that. Add substitution and positioning. Remove lookup. Add a glyph group, or remove a glyph group. Note, all of the project menu commands can also be accessed by using the buttons on the bottom of the main Volt window. The next menu is the Tools menu. We have Compile to compile the Volt tables into usable OpenType tables. Edit Glyphs to edit glyph properties like name, type, Unicode value, or number of components. Edit Glyph Groups will open the selected glyph group. You can also open it by double-clicking. Edit Lookup, the Proofing tool, and the options to change settings for things like preferred glyph size for viewing in Volt, CMAP types, and other compilation options. These values are saved into the font. This tool menu can also be selected from the toolbar on top. The next menu is the Import menu, where we can import glyph data from a previously saved file for a glyph range by Unicode values or import a CMAP table. Can import lookups from a previously saved file or import a glyph group from a previously saved file. The option to import PostScript names will import names from the post table of the font. This is an easy way to match glyphs to user-friendly names for use in Volt. You can also import the whole project, which will import all the Volt data from a previously saved file. That will include the glyph data, the writing system, the lookups, as well as the glyph groups. And the Export menu is used to export glyph data, lookups, the glyph group, or the whole project. The main Volt window is divided into three sections: the writing system area, the lookup list, and the glyph groups. The writing system is displayed in a tree control format. Here the scripts are defined, languages are assigned to the scripts, features are assigned to the languages, and lookups are assigned to the features. Notice in this font, there are several different writing systems. The lookup list contains the list of lookups specified for the font and are listed in the order in which they are applied. To change the lookup order, simply drag and drop to the desired location in the list. Click and drag a lookup to link it to the correct feature and writing system. The glyph group area contains a list of glyph groups created for the font. Let's open the glyph editor window. Here we can edit the glyph name and type, whether it's simple, ligature, or mark, the glyph ID and Unicode value, and you can select the number of components if it's a composite glyph. The Find button is used to search the glyphs by name or Unicode value. Now we'll look at the proofing tool. This tool is used to proof the OpenType features. Set the script and language to be tested. The text flow controls the layout order of the text in the preview. Use alternate to set the alternate number if alternate substitution is used. The features will show the features available for the selected writing system. When a feature is checked on, the lookups associated with it are highlighted. All processing is done in lookup order. The restart, the next, and the next lookup is used to move the OpenType processing through the input text string. Complete will move it to the end of the input string and display the final forms. Type in the name of the glyphs you want to test, separated by a space. Place the cursor in the glyph name and you can step through the OpenType processing. Or you could just hit complete to see the final results. Here, after processing through each glyph, we will see the ligature for the ka and the ra. The text above the display will show the name of the current glyph in the display. These may be different from the input. Here are the links for Volt references, for obtaining Volt, Volt documentation, and the Volt release notes. Before adding OpenType tables to a font, it is important to understand what features will be used with which glyphs. The glyph repertoire in the font will guide the implementation of OpenType tables for the font. Refer to Microsoft's OpenType specs for the individual scripts in the font. Some general steps for adding OpenType tables using Volt would be to first set the glyph properties, then create glyph groups, create substitution lookups, create positioning lookups, create language, script, and feature tree, test the features, and then ship the font. Note, if you open a font in Volt that already has OpenType layout tables but were not created in Volt, Volt will ask to overwrite them. Setting the glyph properties to distinguish base glyphs, ligatures, or classes of marks is information that will be compiled into the glyph definition table, or GDEF. Before setting the glyph properties, we will set up some preferences and import the PostScript names. Start Volt and open a font. Select Options under the Tools menu to set the preference sizes for glyph display. Let's change the glyph size in the grids to 48. We'll keep the presentation size at 72, but let's make the size for positioning a bit larger, like 205. Click OK. Next, we'll import PostScript names from the font's post table. Click on the Edit Glyphs button and scroll to the end to find the last glyph ID for the font. Notice here it is 3316. Under the Import menu, select Import PostScript Names. In this example, we will be importing by glyph IDs. And select OK. If you go back to the glyph editor, you should see the PostScript names if the type developer had put them into the font. Now we'll set some glyph properties. Select the Edit Glyphs, and you would go through all the glyphs to verify the following. All glyphs should have a usable name, easy to remember for building the glyph groups and lookups. You also need to assign each glyph type. For example, if the glyph is a combining mark, you should set it to Mark. Let's find some marks in the font. Here we'll set the circumflex to a mark by selecting the type. If you will be positioning marks over a ligature, the type for ligature also needs to be set on those glyphs, as well as the number of components from which it was made. Let's search for a ligature. Here we want to set the type to ligature, and the number of components should change. We should also check that Unicode values are correctly assigned. Any changes will be reflected in the CMAP table of the font. It is possible to have more than one value assigned for a glyph. You would just use a comma in between the Unicode values. Creating glyph groups can be very helpful in building OpenType lookups. To organize groups of glyphs in which to apply certain substitutions, or build groups that have like positioning for marks or positional forms. Carefully building and using glyph groups not only saves time, but can serve as a reminder to the font developer to make sure all necessary glyphs are used within a lookup. Let's create a few groups for this Latin-based font. Select Add Group from the Project menu, or click on the button Add Glyph Group. When naming a glyph group, be specific as possible, and if your font contains several scripts, it can be helpful to include the name of the script in the group name. We'll start by creating a group for the Latin caps. To add content to the glyph group, select Edit Glyph Group or double-click it. Enter the glyph names one at a time, and you should see the image of the glyph if you have entered the name correctly. You can also enter a range of sequential glyphs by surrounding the first and last glyph name in brackets. For example, A through Z would include the whole range. Create another group for the Latin marks. We'll make one for the above marks and one for the below marks. Double-click to open and type in the names you want to include. You know the names will be correct if you see an image of the glyph to the left. Create one for the Latin below marks. And enter the glyph names you want in the group. As you begin building the lookups, you may find it helpful to create more glyph groups or add to existing glyph groups. You can add or remove groups at any time. Let's look at a few other scripts to see how the font developers have used groups. In this Devanagari font, several glyph groups were created. We see a group for full forms, which includes the whole range, and another group for the range of the full Nukta forms. If we open the lookup for Nukta, we can see how these groups were used. When the full forms are followed by a Nukta, the Nukta forms are substituted. When substituting a list in a group with another group, you must have the same number of glyphs in each group, and they must be in the same order for correct substitution. Other groups include groups for different variations of each base glyph, like this group for the full kaf forms. This group is used in the G+ lookup, and these kaf forms can share the same anchor for placing above marks. In this Arabic font, there are many glyph groups used. Groups for different forms, such as isolated, medial, and final, as well as several other glyph groups. In many scripts, you may also find using groups for glyphs with like widths or heights can be helpful in placing different versions of accents or vowel marks, or in creating contextual lookups. Create as many glyph groups as needed anytime during the Volt project. Use glyph groups in substitution or positioning lookups. Type the less than and greater than sign around the glyph group name when used in a lookup. Assign glyph type to all glyphs in a group. With the glyph group dialog box open, you can assign a glyph type to all glyphs in that group by using the menu option Mark All Glyphs As. This method of assigning glyph type is sometimes more convenient than editing the type in the glyph grid. Before you create substitution lookups, it is necessary to understand the script and language you are trying to support and have all the necessary glyphs created in the font. However, it is not uncommon to begin creating the OpenType tables and find that more glyphs are needed for optimal OpenType implementation. See the OpenType resources on the Microsoft website for OpenType and script-specific documentation. We'll begin by creating a simple substitution lookup for Latin. Under the project menu, select Add Substitution Lookup or click on the Add Substitution button. We'll create one for the dotless I. Type the name of the new substitution lookup. We can use the feature tag in the name. If we have more than one script in the font, we might want to use the script name as well. This will help to keep track of all the lookups. Double-click the lookup to add content. Notice the lookup type is in red. This will automatically change based on the input. Type the lowercase I hyphen, greater than sign, then dotless I. If you have typed the names correctly, you should see the image of each glyph. Note the process marks that should be set to all if marks have an impact on shaping, and none if the marks should be ignored when doing substitution. For example, if a ligature should be formed correctly, even if there's a mark on one of the glyphs. For this substitution, we need to set the context, otherwise the substitution would happen whenever the lowercase I is typed. To use the context feature, we need to simply type the name of the glyph or glyph group in the context area. Here we only want the dotless I to be substituted when it is followed by an above combining mark. Since we created a group for the above marks, we can type in the group name. If you notice a box is displayed, it means I did not type the name correctly. Go back to look at the glyph group to get the correct name. Retype the name and hit enter. You should see the first mark in the group displayed. Now this substitution will only happen if the lowercase I is followed by a Latin above combining mark. Create a substitution for a ligature. Double-click to open, and here we'll type a lowercase f, then a lowercase I, then a hyphen, greater than, then the fi. When making lookups for ligatures, always enter the larger lookups before the smaller ones. This is because the search process will terminate once the first match is reached. Another substitution for Latin could be for the small caps. Let's go to the Arabic font and see what types of lookups are used. Notice the text flow setting is right to left. This setting only impacts the display of the substitution, but all the substitutions are entered in logical order. This font also has Latin, and you can easily locate the ligature lookups for both the Arabic and the Latin scripts in the lookup list. Go back to the Devanagari font. Open the Nukta lookup. This is basically a ligature substitution. When the full ka is followed by a nukta, the precomposed glyph for ka nukta is substituted. We also have a lookup for half forms, substituting each full form with a half form. Note, the context in which the half forms are substituted is determined by the Windows index script shaping engine, so a context is not needed here in the OpenType tables. To understand how OpenType works in conjunction with the Windows complex script shaping engine, read the OpenType specs on the Microsoft website. The specs for the individual scripts will show you how each feature is used and which ones are optional or mandatory. Different types of glyph positioning lookups can be created in Volt and handle positioning in two ways. One is to move a glyph from its original position, like you would use for kerning, or to shift a glyph under a specific context. And the other way is to create an anchor point on a glyph with which to position another glyph, such as aligning a mark over a base glyph. Here is the positioning window in Volt. On the left side, the header contains the lookup name and the lookup type. The lookup type, which was set automatically for substitutions, needs to be set manually for a positioning lookup. This one is set to anchor attachment. Process marks will define the lookup's behavior toward marks. If all is selected, all mark glyphs are processed. If none, then all mark glyphs are skipped by the lookup. Or you can use group and only marks from the group are processed, skipping all other marks. If process base glyphs is turned off, it will skip all non-marked glyphs. You can set the text flow left to right or right to left for the display. You would use right to left when working with languages such as Arabic or Hebrew. In the columns, the names of the glyphs or glyph groups are entered. The shape column shows an image preview. On the right side is the glyph positioning window. At the top are the names of the first and second selected glyphs. Positioning can be done by drag and drop or by entering the exact coordinates. Also shown in the glyph preview are the font metrics: ascender, baseline, and descender. It is advisable that positioning operations do not cross the ascender and descender boundaries, where these glyphs could be clipped or not display at all in the final font. There is also a small preview window where you can enter the ppm size you want to preview. There are options for adjusting only certain sizes and locking anchors, and options to make all anchors for a group the same. Below that is the area to enter coordinates of glyphs or anchors. Here are the glyph positioning types used in Volt. The single adjustment, this is used for positioning a single glyph, usually set in a context. For example, to move a glyph only when preceded by or followed by a certain glyph or glyph group. A pair adjustment is used to position a pair of glyphs, for example in kerning. Each pair is adjusted individually. If a glyph group is used, all the glyphs in the group get the same treatment and positioning. Anchor attachment is used to define mark to base, mark to mark, and mark to ligature lookups. The actual lookup type is defined by the type of glyphs used. You cannot mix different types of glyphs in one lookup. Cursive attachment, this is similar to anchor attachment, but anchor names are fixed to entry for the second glyph and exit for the first glyph. And caret positioning. This data is used in the GDEF table only. Caret positioning does not compile into an OpenType lookup table and cannot be linked to a feature. Let's look at some examples of how the different GPost types are used. Here we see the use of anchor attachment in this Latin font for above marks. And here it's used for below marks. Many scripts can use this anchor attachment for placing marks, like in this Devanagari font. Here is a single adjustment. Note this mark is moved in context only when preceded by these glyphs. A pair adjustment is used here to shift this mark over when preceded by this glyph. And pair adjustment is used here on this Arabic font to kern these glyphs. And finally, the use of cursive attachment is used to assure proper connections in this Arabic script font. We'll begin by creating a mark-to-base lookup using anchor attachment. Under the project menu, select Add Positioning or click on the Add Positioning button. Type in the name of the positioning lookup. Again, it is easier to keep track of your lookups if you name them in accordance with their feature tag and script. Double-click to open the window. Set the type to anchor attachment from the drop-down list. In the Position First column, we will list the base glyphs. Here you can enter each glyph individually, type in a consecutive range of glyphs, or use a glyph group. We'll use the group we created for the Latin caps. In the position second column, we will enter the above marks. Again, the glyphs could be listed individually, but we will use the group we created. The anchor name identifies the anchor to be positioned to. A glyph can have any number of different anchors with unique names. In this example, the cap A has 3 anchor attachments, one for above center, one for above right, and one for below center marks. Moving the anchor point affects both the base and mark anchors. To move only one, you must lock the other. A locked anchor cannot be unintentionally changed until it is unlocked. Here the mark anchor is locked, so if moved, it only affects the position of the base and not the location of the mark on the anchor. Look what happens if we unlock it. Any changes made to an unlocked anchor will be reflected in all uses of that particular anchor in other lookups. It is best to put all members of a class of marks into a group, for example, all above marks or all below marks. Here you can see all the marks placed on the anchor in the same location, making it easy to align a group of marks over a base. Go back to the positioning lookup we started. First, let's name the anchor. We'll call this one above marks. Next, we want to place all of the marks on the anchor so that they can be positioned over the base glyphs. I'll move the anchor so it is easier to see. Drag each of the marks from the mark group to the anchor in the position it would be used when it's placed over the base. Use the up and down arrow keys to scroll through the list in the group. Place each mark on the crosshairs of the anchor. If the font developer has designed these all on the same height, the shift amount in Y would be the same. We'll use the coordinate of 1180 and enter that amount for each of these marks. Once the marks have been positioned, it is important to lock the anchors. You'll need to go through each one and click the box to lock them. This will lock the position of these marks over their anchors. Once they've been locked into place, we can focus on positioning the anchor over the base glyph. To set the position, we can click on the mark and drag it to the desired location. You will see the X and Y coordinates for the first glyph change. Now all the marks in this group have been moved to that location. In the same way, we can position this set of marks over the lowercase. Type in the group for lowercase. The mark anchoring will remain the same. We will just be changing the position of the base anchors. Click on the mark and drag it to the location. Go back to the Latin cap group. Notice we only position the first glyph in the group. We need to place the rest. We can drag each mark to its location, or we can enter the coordinates for the shift. Or we could use the tool that says make all the first the same. Volt will ask to confirm your selection. Now all the anchors for the base glyphs are set to the same X and Y coordinates. While the Y should all be the same, we do need to go through and adjust the X shift. Note, by using groups, we will likely have combinations that are not used, depending on the languages the font will support. You could just list individual glyphs and not use groups, or skip over combinations that would not occur and not worry about setting the anchors. Or you could create a new glyph group with only the glyphs that use those certain marks. In the Volt lookup list, you can easily determine the type of lookups by the small icon next to the name. Remember, lookup order is important, and substitutions should come before positioning lookups. Let's look at some other anchor attachment lookups. We can easily find them in the lookup list by the positioning icon and how they were named. Here is one for the Latin below marks. Notice in this example, a glyph group was made that contains only the bases that would be used with this particular below mark. Let's find a mark-to-mark lookup. These are created in the same way using anchor attachments. Here, the same glyph group is used for both the first and second positions, placing one set over the other. Note, anchoring does not have to be for just above or below positioning. And we'll see in this Hebrew lookup, the holum is placed on the inside of many of the glyphs. Notice here too, it is being placed over the dotted circle. In many scripts, if a user types an invalid combination, the mark would appear over the dotted circle. So it can be important to create a position for that as well. And finally, let's find a mark to ligature lookup. This is similar to defining mark to base lookups. The only difference is defining positions for many anchors per ligature instead of just one for a simple base glyph. You create one anchor per component. The currently active component is controlled by a drop-down box above the positioner. The inactive component anchors or marks are grayed out. When more than one mark follows a ligature, the first is placed over the first component, the next would be placed over the second component, and so on. This ligature has two components, so anchors for each component have been created. And in this example, we see three components. A separate set of anchors were created for the group of below marks as well. You can review the positioning at various sizes using the small preview window. If you see a size you want to change, we'll use the Adjust at this size checkbox to make positioning adjustments. Use the arrow key to scroll up and down the point sizes. For example, here at 17, the diaresis looks too far to the left. We can drag it over, watching the display in the small preview window. Notice this will not affect any other sizes. To remove, uncheck the Adjust at this size box. This tool can be very helpful for making minor adjustments at certain sizes. Be aware, however, that hinting will also affect the pixel placement. Let's look at a single adjustment using a context. Here we see these two tie glyphs are being moved using a single adjustment. However, the positioning will only occur in the defined context. If preceded by a certain glyph and if followed by another defined glyph. We can open the proofing tool to see how this would work. First, select the tie script in the font. Next, I will copy the glyph names of the three glyphs. The middle one is the one being adjusted. If we proof with no open type selected, you will see the mark is crashing into the base. Now we'll click on the open type. Notice the lookup type for single adjustment falls under the current feature. When we hit complete, we will see the single adjustment has been applied. There is a pair adjustment for the tie script. No context is used, but this adjustment will only happen when one of these three glyphs follows any base glyph from this glyph group. In the example, the width of the first glyph is adjusted to turn the two glyphs closer. Notice the original location of the glyph is shown in gray. Pair adjustment can also be used to shift up and down. Here it is used to move this anudata sign below the mark. The shift is entered in the Y. Let's review what we know about lookups. Lookups are executed in the order of the lookup list. We can drag and drop to change the order. Remember, order within the lookup is also important. Use the feature tag and script name in the lookup name to help organize your lookup list. Context can be set when creating a substitution or positioning lookup. Create unique anchor names based on attachment locations. And use glyph groups for bases and mark glyphs for more efficient substitution or positioning. And finally, review Microsoft's OpenType specs for required GPOS and GSub lookups. Now that we have created our positioning and substitution lookups, we need to create the script, language, and feature tags under which the lookups will be applied. This allows the lookups we have defined to work when the font is called by an OpenType engine. All glyph processing is defined within a context of script and language system. Let's go back to our sample font. Select Add Script from the project menu or click on the Add Script button. Rename New Script to Latin. Type the four-letter tag for Latin between the left and right arrow keys, or greater and less than sign. When you hit Enter, Volt will fill in the name. The 4 characters between the brackets are the tag that is saved in the font. These script tags can be found on the Microsoft Font Development website. You will notice that the default language tag was added when we created the script. If you need to support several language behaviors within a script, you can add another language. Select the script and under the project menu, click Add Language or use the Add Language button. Rename the new language to the 4-letter tag for the language needed. Again, you can find these language tags defined on the Microsoft website. Note, we could have set up our script, language, and feature tags before creating these lookups. Okay, go back to the default language and we'll create some features. Let's start with the CCMP. Again, when you hit enter, Volt will fill in the correct name. We'll create a few more features for our sample font. Let's add a feature for ligatures and one for the marks. Now we can simply drag our lookups to the correct feature. Using OpenType allows a font developer to support more than one script in a font, as well as support many language systems under each script. Let's look at some examples of how several scripts may be supported in one font. In the Microsoft Arial font, we can see that Arabic, Cyrillic, Hebrew, and Latin are all supported. Notice that Volt sorts the script tags as well as the language tags in alphabetical order. This does not affect the processing order in the font by the shaping engine, which is based on the script and language system. The tree configuration that Volt uses allows you to collapse or expand the information. To remove a tag, select it and click the Remove button. Notice if we remove a feature, it will remove the lookup associated with it as well, but does not remove it from the actual lookup list. To do that, you would need to remove it from the lookup list. While many features can be associated with various language systems, there are certain features designed to take advantage of the language system tag, like the localized forms. Using this, you could substitute alternative glyphs that may be preferred for a particular language. There are different ways to achieve the same results using OpenType, and the font developer can decide which language will be the default language and when to create an additional language. If he does so, he must be sure the application will support it. Here we see that Arabic script is also supporting Urdu. If we compare the features, we will see that most of them are identical between the two languages, but there may be different features applied only to the Urdu. For example, here we see the localized form. If we open that lookup, we can see that this is substituting the Arabic with the Urdu style numerals. This substitution would happen only if the application supports Urdu. Otherwise, the default would be the Arabic. To review, multiple scripts can be supported in one font. Multiple languages can be supported within a script. Use the local tag for language-specific features, and review the OpenType specs for supported features and lookup ordering. The OpenType spec overview, script, language, and feature tags are listed and defined on the Microsoft website. Before testing the lookups, the OpenType tables need to be compiled. Volt will go through all of the lookups to compile the information. Any errors will be flagged and the font will not compile. For example, if you reference a glyph in a lookup that cannot be found, if it's missing or incorrectly named, or if a lookup type is set incorrectly. If you do get an error, fix the problem and try compiling again. Note that compiling may take a few minutes if you have several lookups in the font. It's a good idea to compile your work after each new lookup is created, and this will help in tracking down any errors. To compile, select Compile from the Tool menu. You can also use the quick key F7 or click on the Compile button. Now let's open the proofing tool. Using our sample font, we'll set the script to Latin, the language to default, and keep the text flow left to right, and we'll check on all the features. We'll test the dotless I substitution, enter the glyph names, and hit Complete to process. If you click Restart, you can see the glyphs before the OpenType is applied. Let's test some other features in a Devanagari font. After selecting Script, Language, and Features, I will type in the glyphs for a ligature substitution. Click to see the processing. Here are the glyphs before applying the OpenType features. Click Complete for the final results, and here we see the Casa ligature. The resulting glyph name is also shown above. Next, let's enter a longer string of text. Making sure to type the names correctly. Here are the glyphs before the OpenType has been applied. And if we click Complete, here are the results. Notice this box. That means I've typed a glyph name incorrectly. I'll go back and look up the glyph name. And here are the correct results. Let's proof some Arabic glyphs. Remember on this to set the text flow right to left. We'll enter the glyph names, and first we see the glyph shapes before the lookups have been applied. Note that Volt may ask you to recompile the font before processing. Select OK, and here are the results after recompiling. Let's go back to the Devanagari font, and if you place the cursor in a glyph name, you can use the Next Glyph button to walk through the selection. The box will show the current glyph. You can also use Next Lookup to process the lookups in order one at a time. Here we see the Ref feature being applied. We can continue through the lookups, and the next one to affect this particular string of text is the Half feature. To use Volt's proofing tool, select Script and Language System to proof. Set the writing direction, click boxes next to the features to be tested. Lookups for the features will automatically be selected. Enter text by glyph names separated by a space. You can step through the glyphs to see each lookup applied. Use the Complete button to process all lookups selected and display the final results. Remember, lookup order in your lookup list is critical for correct OpenType processing. After you have tested your font and you are ready to ship it to a user, you can select Ship Font from the File menu. This will strip out the Volt working tables. Ship Font will allow you to save your font to another name. so you can keep the source font with the Volt tables intact. You will only be able to edit the version with the Volt source. First, we will review the export and import options. Starting with the export, the first option is Export Glyph Data. This will export the data for a range of glyphs by glyph name, glyph ID, or Unicode value. The data exported includes the glyph name and glyph type. This info will be saved to a VTD file. Export Lookup and Export Glyph Group will export the currently selected lookup or group and save it as a VTL for lookup or a VTG for glyph group. Export Project is used to export all data including glyph definitions, glyph groups, lookups, as well as script language and feature tree. The file extension for the project is VTP. Now we'll move on to the Import menu. You can import data by glyph range from a previously saved VTD file. It is critical if doing a range that the glyph order is identical in both the source and destination fonts. You can also import the CMAP table. Import Lookup or Glyph Group will import a previously saved file of either type. Use Import PostScript names to assign the glyph names from the font's post table to the glyph names used in Volt. And lastly, Import Project to import all the OpenType data in Volt source, including GDEF, GPOS, and GSUB. Import Project works well if you have the exact glyph order in both the source and destination fonts. For example, if you have done the OpenType in Volt for a Roman font and want to import everything for your identical italic version of the font, then you'd probably only need to tweak the GPOS lookups or create some additional substitutions that may only apply to the italic style. Let's export some tables. In the Arial source font, we'll export a Latin glyph group and a Latin lookup. Select a glyph group. Click Export Glyph Group, and we'll save it with the same name. Now export the Latin IPA lookup. Select the lookup, select Export Lookup from the Export menu, and save the file. We'll go back to the sample font we started. Select Import Glyph Group, select the file, and click OK. It will add the group to our list. If we open it, we can see that the glyphs are named the same way in this font. If they were not, we would see empty boxes. Now import the Latin IPA lookup. It will also appear in the lookup list after our last selected lookup. This may need to be changed to the correct location. You can double-click to open it and make sure the glyph naming is the same. Let's look at a situation where we could use the Import Project option. Here I have a Thai font with all the Volt OpenType complete. I also have an italic version of the font with the exact same number of glyphs and glyph order. We see 354 glyphs in this font. Choose Export Project. We'll call this Thai Volt Project and click Save. Now we'll open the Thai italic font. We'll see that it has no OpenType data, and we can see that it has 354 glyphs as well. Select Import Project, and Volt will warn you that if this font did have OpenType, the imported data will overwrite it. Choose Yes and select the project. Here's all the imported info. You should open each glyph group to make sure all of the glyphs are there. Also check each lookup and make any necessary changes. On this positioning lookup, because this font is italic, we may need to make some adjustments. But you can see how using Import Project can save a tremendous amount of time. Make sure to always compile to check for any errors. You can import and export multiple lookups or glyph groups by selecting more than one. You can also select multiple lookups to drag and drop to a particular feature. Let's go to the Arial font. Click on several lookups using the Shift key or dragging around the selections. Choose Export Lookups from the Export menu. These will be saved into a single file, but when you import the file, all the lookups will be listed separately. Next, open our sample Latin font. We'll select Import Lookups, choose the file we just saved, and click OK. And here are all the individual lookups imported. Of course, you would want to make sure to also import specific glyph groups if they are being used in the lookups. Now select all of these lookups and drag over to the correct feature. So far, we have learned about two types of substitutions. One that always happens for a particular feature, for example, a ligature or a medial form being substituted in an Arabic font, and a contextual substitution where the substitution happens only in a given context. Think of the dotless I that we substitute only when followed by an above combining mark. There is, however, another type of substitution or positioning you can create in Volt. If you type the word except in front of a context, whether it be a single glyph or glyph group, the substitution will happen all the time except when the context is matched. Some font developers find this option very helpful in some complex script fonts. Of course, there are many ways to achieve the same results when building your OpenType tables. For example, if a substitution is to happen nearly all of the time, except a few circumstances, then the use of except may work well. But if there are many exceptions, the alternative version of the glyph should be used as the main form, and the other form can be substituted only in a given context. The font developer can decide which would be less work and make the most sense for his font based on the script, language, and user expectations. Let's look at this Devanagari font. Here we see the use of except in this G sub lookup. It's easy to spot because of how it was named. Open the lookup, and here we see the halant and full ra is substituted by the va2, except when it is followed by a full rakar form. The exception applies to any of the glyphs in this glyph group. Next, open the proofing tool. First, we'll turn on all of the features. Let's type the halant and the full ra. Before the OpenType is applied, we can see the nominal shapes. Hit complete and we'll get the va2 form. It's a bit hidden because of the zero width. Now we'll try a glyph we know that does not have a rakah form, like the cha. And we see the substitution happen, substituting the va2 form of the ra. Now try a ka with the rakar. And the rakah form of ka will be substituted. If we try the ka ra, we will see that the va2 is not being substituted, and instead we'll get the half form of the ka ra and the full form of the ra. Some common errors Volt users experience when testing their OpenType fonts are substitutions not happening as expected. Check the lookup order. It must follow the script's OpenType spec. The order within the lookup is also important. For example, substituting the longest ligature before a shorter one. You should also consider previous substitutions when building the lookups. And by using the proofing tool and stepping through each feature one at a time, you will see how the OpenType is applied, and it will help to track down any errors. Missing glyphs, make sure the glyph shapes appear when you're creating the lookups or the glyph groups. Check the naming. Use sequential order when substituting ranges or groups. This is important for correct substitution. Know how the shaping engine is working with the OpenType features. And remember, all lookups must be applied to a feature in order for it to be processed. Another common problem is accents or glyph parts are clipping or missing on screen or in print. Make sure to keep your glyphs within the font metrics, the ascender and descender values. Check your anchors, keep your mark placements inside the metrics, and consider hinting, which can shift pixels out of the font metrics at small sizes. This concludes Microsoft's training video on Volt. Thank you for watching. For more information on Volt and OpenType, please visit Microsoft's typography website.